Good afternoon. My name is Michael Caterino. I'm based at Clemson University in South Carolina. But today I want to talk to you about some work that I did during a sabbatical in Ecuador last year on Selaphine Staphylinids, primarily in Ecuadorian cloud forests. So I've been at Clemson long enough to earn a sabbatical, and I decided that Ecuador would be a really good place for this because of the diversity of beetles, no surprise to any of you in the audience. Um, and I had some connections there from some previous work that I did, as well as an Ecuadorian graduate student that I had here at Clemson. So I moved my family down to Quito in July of 2024 and stayed for just about a full year. And I was hosted at INABIO, the Instituto Nacional de Biodiversidad, right in La Carolina Park in the center of Quito. It's a fantastic place to spend some time. So part of the reason for doing this was that I had some collections from previous work that I did there in 2011. I went for 3 weeks, really as part of a hysterid project, but there was a lot of bycatch, and that had a lot of selaphines in it. So I'd always kind of wanted to do a little bit more with that, and this seemed like a good opportunity. So overall, my interests during the year were to document selaphines from as many different habitats and places as I could manage. Cloud forests was kind of the main focus, both because they're generally undersurveyed and because of the montane topography, I expected them to be relatively um, diverse with higher local endemism than it seemed to be the case in lowland forests. Uh, I wanted to use this as a bit of a test case to look at the feasibility of doing sort of a rapid taxonomic approach in a very diverse, hyper-diverse environment. I wanted to kind of use this as an opportunity to develop some new collaborations with researchers in Ecuador, so to maybe facilitate future work. And then I wanted to just kind of make it easier for anybody to work on this hyper-diverse fauna in the future, kind of develop some basic foundational resources, such as well-illustrated publications. If you look in the older literature on these things, that is the opposite of the case. Um, there's very few species level keys for anything. DNA barcodes now can help to identify many of the species, so I wanted to barcode as many things as possible. And another challenge that they often have is not having access to good reference collections. And most of those collections are in other countries. So I wanted to develop an in-country reference collection for selaphines. So to give a little bit of background, I'm sure that most of you are at least somewhat familiar with Ecuador's habitat diversity. It's one of the smaller countries in South America, but it includes an incredible variety of habitats. So from the coast, things rapidly ascend up to the Andes with very high montane, even alpine habitats. The coast itself is often dry. There's sort of seasonal rainy seasons. And a lot of the species that you find there seem to have affinities to that kind of coastal seasonal forest that you find in Central America. Um, on the eastern side, you've got just a bit of the vast Amazonian region, and that's humid, wet year-round. But a lot of those species that you find there do seem to have broader distributions because the habitat there is at least a little bit more contiguous. Um, from about 1,500 meters to 2,500 meters in the mountains, you get these cloud forests, which are cool and very, very moist on both the Pacific slope and the Amazonian slope. So I was kind of interested in comparing those two sides. And then above the cloud forest, you get into this alpine paramo that goes all the way up to snowline on some of the higher volcanoes. That's a very unique habitat, and I'll mention a few things that were found in Paramo. And then right along the spine, you kind of have these dry valleys between the eastern and western ridges. And this was surprising. I really wasn't familiar with that at all. And honestly, I didn't sample that all that much, but um, it is really interesting to see, things like cactus and agave growing in these high elevation dry valleys like you find around Quito. So again, probably most of you are at least somewhat familiar with selaphines, although they're somewhat more of a neglected group within rove beetles. but they may well be the largest subfamily of rove beetles. I know Aleochorions may, they're definitely a contender, but with a little over 10,000 described species now, there have been estimates that there might be over 100,000 species of Pselaphines. Nobody really knows. And of course, most of them are really tiny, generally 1 to 2 millimeters. Some of the giants, maybe 6 millimeters, but I don't know of any species much bigger than that. Most of them can be found in leaf litter, although a lot of them have more specialized microhabitats within or around the leaf litter. And then, of course, many species like this claviger in the center are myrmecophilous. We don't really know the extent of that across the subfamily more broadly. Previous work in Ecuador was very limited. Only 13 species had been previously reported in the literature, although some work that Chris Carlton did in Yasuni found almost 200 species over, I think it was about a 7 or 8 week sampling period. None of those, unfortunately, have been named yet. So the samples that I had to work with came from fieldwork that I was able to carry out both in the 2011 trip and during the sabbatical. But I also was able to combine that with a lot of existing collections that they had at Inabio. And then, a lot of people there were kind of going out and doing field work at various times. So, once they knew I was interested in leaf litter stuff, they would sample leaf litter and bring that stuff back. So overall, we had samples from really a pretty wide variety of habitats, covered most of the country reasonably well, at least in the northern half. Southern part, much more sparsely sampled, but that's something that it would be fun to go back and do more with. Sampling methods are, again, probably pretty familiar. Sifted lots of leaf litter. I was able to set up a Berlese tent outside in the parking lot behind Inabio. And then you get these wonderful, rich samples to sort through. I'm sure you can see some of your own favorite Staphylinids in those samples. After that, of course, all that stuff was sorted to morphospecies. But then on the lab side, Inabio had a molecular lab in a different building associated with the herbarium, where we did a hotshot, kind of quick and cheap extraction procedure. Down here you can see Andrea, one of the undergraduate students that I worked with there, doing some of that work. We amplified these with sort of the universal CO1 barcoding primers. We were able to do nanopore sequencing there in country. And then we used Amrita Srivatsan and Rudolf Meyer's ONT barcoder to demultiplex all this stuff and kind of generate matrices. I'd love to spend an hour telling you about all the great places that I was able to sample, and it was really, really fascinating and wonderful. This will just have to do for now as kind of a taste of some of the different places that we went and things that I saw. There were a number of challenges along the way, as you might expect working in a tropical country. One of them, about halfway through the year, I had a pretty nasty fall and probably tore my meniscus. I never got that verified, but I was hobbling around pretty good for the last half of the year. I love these signs in Quito. There are a variety of natural hazards that you might not have been aware of. Some of these were originally earthquake signs, fire, volcanoes, but I love that these were modified by people with alien abductions. Here's a Godzilla attack. Another one had a kraken chasing the little man. So you really had to be on your guard in Quito. And then one morning, I was the first one in the lab and discovered that a specimen dryer had gone up in flames. And this smoked out a lot of the lab, and we were out of the building for a couple of weeks while this was all cleaned up. We were just so incredibly fortunate that it didn't spread beyond just that one desktop. But yeah, that was really quite sobering. Okay, so altogether, all my sampling and the other samples that I was able to work with, we pulled out about 3,500 specimens from 115 different samples, sorted those to almost 600 morphospecies based on external characters at first. 60 of those turned out to be only represented by females, so those were not really worked with further. Once we were able to look at genitalia, I was able to match up a number of these that seemed to be just slight variations or in some cases polymorphism, whether sexual dimorphism. or some real polymorphism even in males. And then some of these morphospecies were in subtribes, Trimiines especially, that I'm still not real comfortable with. And figuring out the genera of a lot of these things based on the literature was its own sort of huge challenge. But there's a number of things down there that were sorted but still not worked with. And out of all of those, two of the species turned out to be things that had previously been named. And it just happened that I was near some previous type localities. So altogether, I ended up with 375 species that I decided were worth describing. And about 52 of those are being put in 18 new genera. So a lot of diversity. Some of it couldn't even be placed in existing genera. The barcoding was not especially successful. Out of about 600 extractions, I only got about 200 barcodes, and those represented about 128 species. I'm not really sure all the reasons for this. It was pretty clear there was some primer bias. There were some genera that did not sequence well across the board. So Arthmius was one where I just think there was too much primer mismatch with those standard primers. So those, we have the extractions and could probably go back and get more. In other cases, though, I think that there was some inconsistency in things that mostly should have worked. And I think this hotshot extraction procedure is probably not very reliable. I don't know. There's something maybe we could clean these up and get more from them, but I don't really know. It was a bit disappointing for the amount of effort that it took. As for trying to estimate total Pselaphine diversity, bottom line is really we're far from being able to do that. As you can see, the places that I had sampled slightly more thoroughly, the species accumulation curves are still climbing precipitously. So we could make estimates from these, but without any hint of an asymptote, it's really premature. So, and put this into context, I mentioned Chris Carlton's work. Over the 7 weeks that he sampled at Yasuni, they got 178 Pselaphines out of 140 samples. And that curve, the lower one here, was still rising, pretty good clip. I think his estimate ended up being 220 some based on some estimators, but there was still a long way to go, even there with that level of sampling. So really, we'll need to do a lot more sampling at all these sites to have any sense of what the total diversity might be. Okay, quickly I want to go through some of the results with respect to a few of the major genera. One of the ones that I kind of quickly glommed onto was this genus Bibrax, and this had not been previously reported at all in Ecuador. And there'd actually been some recent work on these. Metopiacini have been fairly popular in the recent literature. And in fact, my co-authors on this paper, David Diaz and Yorina Tupui, had already kind of been looking at some of these and thinking they'd be fun to work on. So we ended up describing 12 species in Bibrax, found across most of the country, at least all the major biomes. And then they've found 4 more of these since I left. So there's going to be quite a bit more to do here. Did some work on Panabachia. So I mentioned I'd had a graduate student previously from Ecuador, Sofia Munoz. She was here with me at Clemson from 2015 to 2019, I think, and is now back in Ecuador and working at Inabio. But we took the opportunity to do some work kind of based on her dissertation, which had been in Paramo and looking at litter beetles there. So this genus Panabachia previously had only been known from 2 described species in Central America, and now we've added 24 just from mainly her sampling in Paramo and Ecuador. A couple of these get down into cloud forest elevations, but for the most part, this genus is exclusively high elevation. Another genus many of you might be aware of is Arthmius. This is maybe one of the biggest Pselaphine genera in the neotropics. 101 species had previously been described, and I'm going to be adding 41 more of these. They occur from the coast all the way up into Paramo, with some interesting lineages that seem to be specific to each. They're nice to work with in terms of morphospecies sorting, in that they usually have pretty good sexual dimorphisms. You can see several on the heads here, on various parts of the legs, sometimes on the antennae. But even there seem to be species within those dimorphism sort of morphospecies. So they still mostly need to be dissected, but the genitalia are relatively informative. And then another genus that I really came to like is Jubus, another probably megadiverse genus. Only 55 of these have been described, but I'm adding 72 to that. Again, all major biomes. In most cases, the females here are flightless and micropterous. In fact, I think all of them. In some cases, the males are also flightless and micropterous, especially at the higher elevations. But then there seem to be some where the males are polymorphic, some flying, some not, based on genitalia. And these, again, there's a few gross characters you can sort based on external morphology, but the male genitalia are really essential. And again, pretty informative for species differences. This is just a sampling of some of the new genera out of 18. I wish I could go into detail on all of these, but there's not time today. One of the other interesting things that I can't say I discovered, actually, Joe Parker and Chris Carlton have noticed this before, but juvines pretty universally seem to have these maxillary glands that exude these, what I've been calling noodles, some kind of secretion that hardens. And we're guessing that this is probably a prey capture mechanism, that they ensnare collembolans or whatever. Joe actually has now some samples of these that he's analyzing chemically. We're hoping to understand these a little bit better in the near future. So to wrap up, so far we've got 3 publications out on these. So we got the Bibrax, Panabachia. David, Urena, and I also published a couple of new species of Metopiellus earlier this year. My big monograph on most of the other species actually was just accepted by Megataxa, their subjournal. So that should be coming out hopefully sometime this summer. And then Don Chandler and I are slowly working on a key to all the neotropical genera of Pselaphines. So like I say, it's slow, but I think we're going to get there on that. So you have that to look forward to. As for the collections, I mentioned earlier, it was really my intention to leave all these things in country. So now all my types are at Inabio, Universidad San Francisco, as well as the Católica. So they're there, they're available. I've also left all my bulk samples there, so there's lots and lots of more material. I did try to mount most of the staffs that I caught from the litter, so there are some good staff backlogs already ready, sorted, ready to go. I actually met and worked a little bit with one of Dagmara's students, Karen, while I was down there, and she's looked at some of these Peterines as well. As for kind of the overall prospects, well, we've got a long way to go for Ecuadorian Pselaphines, let alone neotropical Pselaphines as a whole. But I'd like to think that I made it look a little bit more feasible to, in a year, get through a pretty substantial chunk of diversity. And I think this work's going to make it a lot easier for people to do this in the future, which I hope to do as well, and go back, annually or so and sample some new sites and add to the effort. So with that, lots of folks at Inabio to thank. It was really a great place to spend a year. I made a lot of great friends, and I can't wait to go back and see everybody. Lots of folks helped out with the field work, especially I'd like to acknowledge Giovanni Onori, a legend of Ecuadorian entomology. He runs a field station at Otonga that was really the first place that I went and spent serious time. Many other folks helped out along the way, as well as people in the collections at San Francisco de Quito and the Católica. And then I also have to thank my family, my wife and 2 boys for supporting this effort and going to Ecuador with me for a year. It was just a great experience for all of us. So with that, I'll wrap up. Thank you very much, and enjoy the rest of the meeting.